There is much more than following standard procedures when solving indeterminate members. Check out these examples here in mechanics of deformable bodies. The problem has a rigid bar pinned at A and also attached to two vertical rods. The first rod nearest the fulcrum is steel of 2 meters length and 300 square millimeter area. The rod at the end of the bar is a 3-meter bronze of 500 square millimeter area. The task is to identify the largest load P that can be applied at the left end if the allowable stresses of both rods are 150 megapascal for steel and 70 megapascal for bronze. The first equation to use comes from equilibrium, and with the presence of a fulcrum, there occurs a pair of reactions. Draw the free body diagram of the bar where the load is placed at the left end, followed by the horizontal and vertical reactions at point A. Then, place the forces from the steel and the bronze rods. Then, taking the summation of moments at point A, the first equation becomes 2.5p as equal to twice of the load of steel and 4 times the load of the bronze rod. This is taken as equation 1. Next is to work on compatibility equations. The easiest to visualize is through deformation. With the application of load P, the bar then rotates counterclockwise from the fulcrum, which creates deformations in the two rods. Using similar triangles, we can relate the deformation of steel is to 2 meters as equal to the deformation of bronze is to 4 meters. To convert the deformation into load as we are looking for loads, we use the deformation equation. Then the compatibility equation becomes PL over AE of steel over 2 as equal to PL over AE of bronze all over 4. We then plug in values. P of S times length of 2 meters all over the steel area of 300 square millimeters times 200 GPa is equal to 2/4 of the load of bronze times 3 meters length all over 500 square millimeter area with 83 gigapascal. Note that units cancel out with each other, leaving P of S as equal to 90 upon 83 of P of B. This is then the second equation. Place equation 2 into equation 1. That is 2.5P is equal to twice of P of S, which is 90 over 83 of P of B, plus 4 of the load of bronze. Distribute external factors and have 2.5P as equal to 180 over 83 of P of B plus 4 of P of B, which is simplified as 2.5P as equal to 512 over 83 times P of B. Label this as equation 1 prime. So far, we have two equations with P variables, so we need to figure out how to come up with the values. Take note from the premise that we are given the stress values. But how do we use stress in the solution? Analyze the effect of the load to the system. If load P is maximized, which rod will be stressed largely? Between the steel and bronze rods, the bronze rod will be stressed largely due to its location. The stress equation is then integrated in the solutions, where P of B is then the stress of bronze times the area of bronze. To maximize stress, The allowable 70 megapascal is used for stress times 500 square millimeters area. So the largest load for the bronze rod is 35,000 newtons. Now plug P of bronze into equation 1 prime and get 2.5P as equal to 512 over 83 of 35,000 newtons. The total load is then taken as 86,361.446 newtons. In case we want to know the load of the steel rod, we use the second equation, which was 90 upon 83 of 35,000 newtons. The load of the steel rod is then 37,951.807 newtons.